All right, so for the 17A questions, number 1, we have the redox equation. 2 potassium plus Br2 creates potassium bromide. So it wants to know A is what is being reduced, and the next one is what is being oxidized, what is the reducing agent, and what is the oxidizing agent, and then how many electrons are exchanged. So I'm just going to go through this one and answer it basically all at one time. So potassium, we know when it's by itself is 0. And then Br2, when it is a diatomic element, 0. Then here, potassium is in group 1, so +1. And then Br is going to be -1. Okay? So potassium goes from 0 to +1. So the magnitude of change is +1. Br2 goes from 0 to -1. So the magnitude of change is -1. Okay? So that means that potassium is losing electrons. So the one that is being, well, first ask what's reduced. So which one of these is the oxidation number is going lower or is being reduced, meaning it's gaining electrons? That's going to be bromine. So Br equals reduced. And then for potassium, potassium is giving away its electrons. It's losing. Losing electrons is oxidized. Okay? Then remember, whatever is being reduced is going to be the oxidizing agent. So bromine is going to be your oxidizing agent. And that makes potassium, the one being oxidized, your reducing agent. And then the fact that potassium is giving 1 electron to Br2 means that only 1 electron is being transferred or exchanged. Okay? If I hold it this way, it'll be better. All right, for number 2, there are multiple ones. For each of these, we need to figure out first if it is actually a redox reaction, and then which one's being oxidized and which is being reduced, okay? So we're going to do the same exact thing that I just did in that previous problem. So you have KBr, so potassium is +1, because it's in group 1. Bromine is -1. Cl2 is 0, because it's diatomic, it stands by itself. Over here, potassium, we have +1, -1, and Br2 is 0. Okay, so potassium is staying the same. Br is going from -1 to 0, so that means it's +1. That's how we get from -1 to 0. And then chlorine is 0 to -1, so that means it's -1. Okay, so if Br is going to +1, that means that it is losing electrons, so it's getting more positive. So this is the one that is being oxidized, bromine. Okay, chlorine is going from 0 to -1, meaning that it is losing, or gaining an electron, and its number is being reduced. So chlorine is the one that is being reduced. Okay, so that is a redox reaction. Okay, all right, and then for B, we have this chemical equation. So for sodium, we know this is +1 -2 +1. Okay. This one, we know Cl is -1. We have 2 of them, so copper must be +2. All right, we figure that out based on deduction. And then for the next one, sodium is +1 again, -1. And then for this one, we know OH has an overall -1. We have 2 of them, So this whole thing carries the weight of -2. So this copper is +2. All right. Do we see any changes from sodium on each side? I'm seeing +1 and +1. Oxygen, I'm still seeing the same. Hydrogen, I'm still seeing the same. And I'm seeing the same for copper. So no exchange of electrons is happening. So this is not a redox reaction. Okay? All right, for the next one, Mg is 0 because it's standing alone. Iodine is 0 because it's a diatomic. And then Mg is in group 2, +2. And we have to have two I's to balance out this +2. So that means I is -1. It's also in group 17, if that helps. So magnesium is going from 0 to +2. So it is losing 2 electrons. Iodine is going from 0 to -1. So it is gaining an electron. And there's 2 of them, so that's happening twice. So that means that magnesium is being oxidized because it's losing electrons. And that means that iodine is being reduced because its oxidation number is going down because it's gaining electrons. Remember, Leo the lion says GER, so lose electrons oxidized, gain electrons reduced. All right? All right, for this last one, this one is a little bit more involved because after we do the steps that we've done in these problems, we have to do a little bit more work. So for this one, it says balance the following equation using the oxidation number method. So we're going to do the exact same thing that we were doing up here. So copper is by itself, so 0. And then we know hydrogen is +1. Oxygen is -2. There's 3 of them, so it has a total weight of -6. And with that +1, we're at -5. This whole thing is neutral, so that nitrogen must be +5. All right? Now for the other side, we have NO3. We know from memorization, this whole thing, when it's in parentheses, you can keep it together. It's -1. We have 2 of them, so it has an overall weight of -2. So that must mean our copper is +2. All right. And then for the NO2, we have a rule for oxygen is -2. There's 2 of them, so -4. So that must mean that nitrogen has an overall of +4. Okay. Then we have our H2O is +1, -2. There's 2 of them, so that has an overall of +2. Okay. Now, I'm only showing you these to show you how I got the different numbers for nitrogen. Normally, you would just assign them, but for those of you that are a little confused on how I got those numbers, that's why I did that math for you. All right, so let's look at what's changing. Copper goes from 0 to +2. So I'm going to draw a bracket here, +2. And then nitrogen goes from +5 to +4. So nitrogen is -1. All right. So that means that copper is losing 2 electrons. So copper is the one that is being oxidized. And then we have nitrogen is gaining those electrons. So that's the one that is being reduced. So let's go ahead and do the rest of this. So remember in the next steps, once you do this, these numbers need to equal one another. So how do we get 2 and 1 to equal each other? I'm going to multiply them by each other. All right. Now, since I'm multiplying by 1, I don't need to put anything out in front of these guys because that's an understood one. For those of you that would like to see it, just to see what in the world I've been doing, I'll do it for you. Okay. Now, for this -1, we have to multiply by 2. And that's so this exchange equals one another. They balance each other out. All right. So 2 is going to go out in front of the 2 and O2. All right. Now, it wants us to continue doing this by the rest we do by inspection. So just like you guys have learned prior to how to balance chemical equations. All right, so I'm going to rewrite it so it doesn't have all of these like brackets and lines everywhere. So we have Cu plus 2HNO3 Cu NO3 2 plus 2 . All right, so now we're going to figure out how many of each side has. So I can see that my coppers are good. All right, so I have 1 and 1. Now looking here, I have 2 hydrogens and 2 hydrogens. So we're good. Now look at my nitrogens. I have 2 nitrogens and I have 2 nitrogens plus this 2 nitrogens. So that's a total of 4. All right, so I'll write this here. Copper 1, hydrogen I have 2, nitrogen I have 2, nitrogen I have 4 from these 2, and this 2. Next one, oxygen. I have 6, and over here I have 6 plus 4 plus 1. Okay, so we have 11. 6, 4, yeah, okay. All right, so the first thing I'm going to want to fix is my nitrogens. The easiest way to do that is to turn this 2